Hi everyone, my name is Alina and I'm developer advocate for GraalVM at Oracle Labs. And in this session today, we're going to talk about GraalVM, what it is, what it can offer for you as for Java developers, and how you can build cloud-friendly applications with GraalVM. Let's go. First, a quick overview of what GraalVM can offer for you. So one thing is it can give you more performance for your Java applications in JIT mode. So in this mode, you can run your Java applications unmodified just as they are on GraalVM as a JDK and get more performance thanks to new compiler optimizations that are available in GraalVM. So this is one big benefit and one big component of the project. Another one, which you probably have heard of already, is native image. So native image is a technology that allows you to take your Java application and compile it ahead of time into a native binary that will start really fast, need only a fraction of memory, and will no longer require JVM to run. This way, it also makes it great for cloud deployments, right, where you want to use as little resources as possible and also for as little time as possible as well. And last point here is GraalVM is also a polyglot VM. So in addition to Java and JVM languages, it can execute all those languages that we see on top here. So languages like JavaScript, Ruby, Python, R, LLVM. You can execute any of them on GraalVM, or you can even extend your Java applications with libraries from those languages as well. And those were languages. Now, what is interesting, GraalVM is also highly embeddable and can be used in a number of environments and platforms. So those are the ones that we see here below. The first one is OpenJDK. So in this mode, GraalVM can be used to execute your Java applications as they are, right? Replacing top-tier compiler in OpenJDK. And a similar way, GraalVM can also run unmodified Node.js applications. So since it's also highly embeddable, it is also embedded in a database, more specifically Oracle database, where it goes by the name of the multilingual engine, and it can execute JavaScript right there inside Oracle database. And last mode on this slide here is standalone. So this is the native image mode, in which GraalVM is the only runtime required to execute your Java applications as native executables. Now, let's look closer at what GraalVM can offer for Java applications. So one thing you can do, right, we said that GraalVM can act as your JDK, right, where you would run your applications with a Java command as you would do with any other JDK. Another mode is this native image mode here on the right, where it can help you build a native executable of your application first and then run it as native application. So this was the situation up until recently. What happened recently, a couple of releases ago, is we introduced this one more way to execute Java on GraalVM, and it is called Java on Truffle. Also, you might have heard about it as a project called Name Espresso. So Java on Truffle is a JVM implementation implemented using Truffle, GraalVM's language implementation framework. And this is basically the same way as all those other languages are implemented on GraalVM. So languages like JavaScript or Python. And what it does, so it also allows Java to be executed in the way those languages are executed. And this way they can more directly interoperate between each other and share pass data back and forth in the same memory space. What is also interesting about Java on Truffle is that it can also enable a use case where you can create a Java context within your main Java application. So for a separate context. So you can create, let's say, a context for Java 8 within your main Java 11 application. Java on Truffle is a bit outside of the scope of this talk today, but if you want to learn more about it, you can go to GraalVM.org and find our docs there. And in this talk today, we will focus on those JIT and native image mode of GraalVM. Now let's talk about JIT first, where GraalVM acts as a JDK. So in this mode, what happens is you would run your application as you normally would on Java Hotspot VM. We will just replace the top-tier compiler. So instead of C2, you will be using the Graal compiler. And the way to do so would be through using GVM CI. So this is the way this is implemented, right? And GVM CI is a JVM compiler interface through which you can plug in external compiler for JVM. So it is already done, right? This is not something you have to do manually. This is just what happens behind the scenes when you get GraalVM as a JDK distribution and run your apps on GraalVM. And as I said, GraalVM contains a new compiler with new compiler optimization. So many Java workloads will see additional performance benefits by running on GraalVM. In terms of versions, you can get GraalVM for versions of Java 8, 11, and 16. And in this mode, as I said, you can run application as it is, right? No application code changes required from your side, and you can use all your standard tools. So basically, it's a normal JDK as any other JDK you are using. To illustrate that point about performance, I want to show you this sample application. Not this one, but this one. So this is a Java application based on .product, which is a common operation that you would find in domains like machine learning, for example. And you can see a couple of for loops in here, quite a few computations. And also what it will do, it will perform those computations and will provide us information about how long it took to perform those computations so we can compare performance. So let me get to this application. And let me check my Java version as well. So I'm running on GraalVM 21.2, which is the latest release, Enterprise Edition, Java 11. And let me run this application. And what I will do here, I will first run it without GraalVM. So for that, I will just disable GVM CI compiler. So I will be using C2 in this first iteration of running this application. And then I run this application like this. So it will run for a couple of iterations to warm up a bit and show us some more representative numbers. And we can already see that it's computing this data and also shows us the time that it took to compute the table. Should be done any second now. Okay, it's done, and this was running with C2, right? So this second time I want to run it with GraalVM, and for that I will use a script because I want to enable this one new optimization that we got in 21.2, and since it's new and experimental at the moment, I'm going to use this flag to enable it. So let me run this time with GraalVM. We will wait again for the whole application to run and kind of warm up a bit, but I think even visually you can notice how much faster we see this data appearing here, right? So even noted without comparing numbers, you can see how much faster it is. But let's in fact compare numbers, and what we will see here is in our first iteration with C2, table computation times were around 3 seconds on average, I would say. And now with GraalVM, table computation times are around 500 milliseconds, 600 milliseconds, so roughly almost 5x faster. So this is the kind of speed up that you can see when running on GraalVM. Of course, the exact numbers that you will see for your application might be different, and we do recommend testing on your own workload to see what kind of benefits you will find for yourself. But the bottom line here is that speedups like this are possible with GraalVM, and feel free to go ahead and test running your application on GraalVM as well. Now, I also want to share a couple more examples from other teams and organizations using GraalVM and what kind of benefits and they saw and why they are using GraalVM. So one of such teams is Twitter. You might have heard this story already and saw these results because they used to do quite a few conference talks and talk about how they use GraalVM and share their experience with community. So they're running their microservices on GraalVM, and even out of the box, they saw about 12% improvements by switching to using GraalVM compiler, and with some additional configuration, they improved this metric to up until 18%. And they also saw improvements to latency as well. Now, another example, and this is quite recent, is coming from Facebook. So here on the right, you can see their chart where they share the results of Spark CPU usage after switching to GraalVM. and they observed around 10% reduction in CPU usage since the rollout, and they mentioned also that these results were quite consistent ever since they switched to GraalVM. And at the moment, they also say that they migrated most of their CPU-intensive big data applications to GraalVM because they see these important performance improvements by using GraalVM. Now, this was everything about JIT and GraalVM compiler, but let's also talk about native image. So what is native image and why you could be interested in it? Native image is a technology that allows you to take your Java application, compile it ahead of time into native executable, and this way significantly reduce startup time and memory usage of such application. So I guess you can see how this could be helpful for cloud deployments, right? Where this means that you can start faster, you can scale well, and also you can significantly reduce those resources that you're paying for in cloud environments. What's interesting also, native image is very well integrated with many Java microservice frameworks. So if you're starting a new application using one of those Java frameworks right now in 2021, chances are that it's already integrated with native image, and you can leverage native image to get those performance benefits for your applications as well. So very quickly about what happens exactly when you build a native image of your application. So native image will perform analysis of your application, trying to find all the reachable code that needs to end up in this final executable. So it will take a look at your application code, at JDK classes and libraries that it's using, and will also perform something called heap snapshotting. So your application will also come with a pre-populated heap. And it will perform these two operations until it finds all the reachable code, and then it will optimize and compile it to produce this native executable. So this is basically what native image does when you run this command. And yeah, this is how you actually build a native image of your application. So you run native image, and then you can specify that you also either want to produce a native executable or a shared library. And then if it's a native executable, you just run it as a native app. And I want to share with you like how you can get started and build your first application with native image on your own. So one thing you can do, if you would rather try some sample applications that already come are kind of ready for you, you can go to our GraalVM demos repo on GitHub and find those applications there. So we have demos for native image, for JIT compiler, for polyglot, all kinds of applications that you can easily just get from there and run and see how they perform. So if you would rather build an application yourself, as I said, native image works really well with many frameworks in the Java ecosystem. And the first framework that I want to mention is Micronaut. So it's a modern, very lightweight framework for building applications in Java, such as serverless application, microservices, but also basically any kinds of applications as well. And it works really well with native image, so you can build applications with Micronaut and leverage all those native image performance capabilities and benefits. And if you'd like to get started with Micronaut, you can go to their launch page and configure a project for yourself there, or you can use their CLI utility and basically do the same thing from the command line. What's interesting, this Micronaut CLI utility is also a Micronaut application that is built using Micronaut and native image. So if you've been using their CLI utility, you have been using native image already. And again, I want to show you a demo of such Micronaut application. Let me go back to my VS Code. Yeah, so what I have here is a Micronaut application that consists of two microservices, and one of them is for books. So this is an application that contains a list of books with their names and ISBN numbers. So here are the actual books that we have. And another component of this application is the analytics microservice. So this will be used to count the number of times our books were accessed and also expose an endpoint where we can see that analytics data. And those two microservices are talking to each other over Kafka. So let me run them and show you how they work. So I already have my Kafka running here in Docker. And yeah, let me go back here and run the actual applications. So I have those two applications already compiled as GraalVM native images. So here is my Books app and my Analytics app. And let me run them and show them to you. So I see that this is a Micronaut application, right? It started in 164 milliseconds, and it's running at 8080. So let me go here and let me just access proper address. Yeah, so here are our books. And this is the books application, right? Let me also run the analytics one. Okay, it started as well, and I believe it's running on 8081. Okay, let me just go ahead and check it. Yeah, so this is our analytics application, and this will be the counter of how many times our books were accessed. So let me actually access some particular book and see if our counter sees that it was accessed. Let's try this one, and let's go back and update our analytics. So we see that this particular book was accessed one time. And let me go back and maybe access something different and maybe do it a couple of times to see how that will be represented in our analytics as well. So now as I update my analytics, I see that the first book was accessed one time, the second one was accessed a couple of times, and all this data is kind of stored and exposed here in this analytics server. So this is how those two microservices communicate with each other, right? And they are built using Micronaut and GraalVM. And thanks to GraalVM, I think you can notice those fast startup times of those two applications, right? So let me just stop them. So this is the kind of applications that you can build with Micronaut and native image and benefit from those GraalVM capabilities. Now, you also might be wondering, like, what about other frameworks? Like, for example, can I run Spring Boot applications as native images? And the answer is yes, there is something called Spring Native project, which is an integration project between GraalVM native image and Spring Boot. And this is something you can access from GitHub. And as an example, I want to share with you this data from the Spring Boot team. So this was from quite a while ago, from the previous Spring 1, I believe. So I think we will see some new demos and some new numbers from them quite soon. But even back then, the results that they shared was that they were able to compile Pet Clinic as the native image. And the results they got is that startup time was reduced from 2.6 seconds to just 0.16 seconds. And also significantly reduce the memory as an RSS for this application as well. So to get started with Spring Native, you can go to this GitHub project, as I mentioned, and it also comes with all those samples. So you can also get and build it and already try sample applications that it comes with. So those are web applications, functions, cloud, Kafka as well, and so on. Or one more thing you can do if you want to build such application yourself, you can just go to Start Spring.io, and when you kind of configure your project, and you can add GraalVM native as a dependency as well. So this is the way for you to get started with Spring Boot and native image as well. And these are just two frameworks that I mentioned, right? Micronaut and Spring Boot. And in fact, there are many more frameworks that work well with native image as well. You can do Heaven applications, you can do Postgres applications, and basically all of them will offer you this benefit of leveraging GraalVM native image as a way to run your applications with fast startup and low memory usage. And talking about memory usage and overall resources usage, there is one more way to look at native image that I want to kind of show you. And this is, here we are comparing the same application running in just-in-time compiled mode and in native image mode. And here we are looking at memory usage, which is this green line, and CPU usage, which is shown as vertical red lines. And you can notice how the same application uses performs very differently, right, depending on the mode in which you are running it. So in JIT mode, up until something like 3.5 seconds, it is using quite a bit of CPU and quite a bit of memory, because there are some expansive operations happening when you first start your application in JIT mode. Now, in native image mode, since the application is already optimized and compiled ahead of time, you can see how much smaller resources usage is in this case. And this is one of the benefits that native image can offer, specifically in cloud deployments as well. Now, can I make even more out of native image, right? Are there some good tips if I want to use native image, maybe more specifically in my production environment? We've talked a bit about startup performance of native images, right, and how they start fast and use very little memory. But what about peak performance? So what if I want to make sure that the peak performance of my native images is the absolute maximum of what it can be? So if you want to achieve that, one thing you can use is PGO, which is Profile Guided Optimizations. This is something available in GraalVM Enterprise. And what it can offer for you is that you can collect profiling information of your application and then feed it to native image during the image build time. And this way it will be able to build an application and optimize it for specifically those profiles, right, for your specific application behavior. This way optimizing the maximum possible peak performance for your native image. And talking about some more specifics here, so when you build native image with PGO, you can achieve numbers that are comparable to running it on the JDK as well. And one more interesting benefit that I think you can observe here, that in native image mode, what you achieve is that performance is very good from the very beginning, right? So from the very first milliseconds of your application running, it is up and running and ready, in this case, to serve requests. So this is one of the benefits that GraalVM native image gives you. Now, talking about memory management, if you're wondering what kind of GC options are available to you in native image, there are quite a few. So by default, you get serial GC. This is the default option, and it is optimized for low memory footprint. Now, another option that you can use is G1GC, which will be optimizing for improving latency. And this is something also available in GraalVM Enterprise. And as of the most recent release, 21.2, we also have Epsilon GC. So this is a no-op GC that doesn't do any GC. And this is something that you could find helpful for short-running applications that use very little memory. Now, one more interesting update and something that could be helpful for you if you're working with native image. So again, as of recent release 21.2, there is GFR support available in native image as well. So now you can use GFR to also monitor and optimize performance of your native images. For that, you would need to kind of include GFR when you are building your native image. And then also when you are running it, you would need to use a couple more flags to actually start the recording. And let me show it to you. So here I have my GFR demo. And I will show you what it does in a second. Let me just remove my previous recording file. So this is an example application that is quite simple, right? Doesn't do much, but it does contain this one event with an event message, hello developer live. And it was built with GFR infrastructure included. And now let me also run it and actually perform that GFR recording. And for that, I will use this script because I will need to use those two flags as well. So let me run it. So it ran, it didn't do much, right? Because there is no output. So visually, there is no way to tell what this application was doing, but it did generate this recording file for me. So we have a new recording file over here. And let me go to my Visual VM. And in a second, we will be able to take a look at that recording file and see that event that we created. Okay, so this is my Visual VM. Let me just remove this previous file from here as well and upload the new one that we just generated. Okay, here is the file, all good. And let me go to it. And as I navigate to browser, I will see quite a few events here. So first of all, here's our event, right? Hello Developer Live, along with some operating system information, something like JVM information, right? So we can see that this was running on GraalVM 21.2. We can see our command line flags that we used, and we can see JVM names. So here it is subset VM. So subset VM is a VM that comes inside of native images. So all this information is available here inside this recording. So in this release 21.2, we introduced kind of first initial support for JFR, but it will be expanded in the future with our upcoming releases, so stay tuned. And one more helpful thing for you to use if you're using native image. So we have brand new Gradle and Maven plugins that are there to kind of help you simplify building, running, and testing Java application as native images. And one more very helpful thing that they can offer for you is support for JUnit testing in the native image mode as well. So you can make sure that your code behaves in the native image mode just as well, just as expected as it does on the JVM too. So this is also something you can use with native image. And talking about tools, we also have something called GraalVM extension pack for Java. So this is for VS Code, and those extensions help you build, run, and test GraalVM applications. And what is interesting, as of the recent release, 21.2 again, they are also very well integrated with Visual VM. So for example, from VS Code, you can command Visual VM to profile your application, or when you are in Visual VM, you can, let's say you found some performance bottleneck, right? And you can go straight to source, to your Visual Studio Code to fix that issue. So those hopefully will be helpful for you when you're working with GraalVM and native image in particular. And talking about using native image and what kind of benefits you can expect from it, I want to share one more story, and this is from Alibaba, who are using native image in production for quite a while now, so something like I think more than a year, right, year and a half. And the reason they switched to using GraalVM native image is because they observed those significant startup time improvements when using GraalVM native image. So here on the left, you can see their typical microservice application, and you can see that they reduced the startup time of this application by 20x, which is quite a bit. And they also tested the GraalVM native image for their functions applications, and they saw those benefits in terms of memory usage, in terms of duration, but also what is quite interesting in terms of build duration, which got 5x smaller when using GraalVM native image. And this is something they are successfully using in production, and they actually kind of battle tested native image during their biggest sales events when they have huge loads on their servers. So native image performed quite well under such huge load as well. And talking about the project a bit and the roadmap and what releases are currently available. So the latest release is 21.2. As I mentioned, it's available for Java 8, 11, and 16. The next release will be coming up in October. And if you want to see kind of when the next release is planned and when you can expect something new in GraalVM, we have this version roadmap at our website, graalvm.org. Now, if you want to get started with GraalVM, I do recommend going to that website, graalvm.org, because this is something where you can download GraalVM, find docs, find examples, find help. This is basically a go-to place for all things GraalVM. Now, if you want to get started with GraalVM, it comes in two editions. There is Community Edition and Enterprise Edition. So you can download both of them from graalvm.org, or another way to go, you can just go to Oracle Cloud, and this is somewhere where you can use GraalVM Enterprise for free. And we also have this hands-on lab. So if you would rather have this kind of guided workshop experience, you can navigate to this Luna lab, and there you can step-by-step follow instructions and build your first applications with GraalVM as well. Now, the way to get started, as I said, you can download from graalvm.org. If you would like to follow updates, you can follow our social media, such as Twitter. And if you want to get help, we have a mailing list and we have a very active Slack workspace with our community members, our team members. So this is some place where you can ask questions, share feedback, and just connect with the community and the team. With this, that's all, I believe. Thank you a lot. This is my name. This is my Twitter handle. If you have any kind of follow-up questions or if you want to talk about something, just send me a message and I will be happy to talk with you.